Global warming is bringing increasingly wet weather, with intense rainfall and rapid runoff. But are we prepared for the coming storms? Every time it rains, our drainage systems are increasingly put to the test.
The old systems were designed to gather up the flow as quickly as possible, to take it away as fast as possible.
Well, we know that the systems that we've got in place now don't work.
Paved areas, roads and car parks distort the natural drainage patterns and reduce infiltration into the ground. Rainwater that would recharge groundwater or form ponds or wetlands is now washed directly to watercourses. Over the last century, it's estimated that we've lost 75% of our ponds and the wildlife that depends on them. Waterways are now rarely a feature of the townscape. Our drains and sewers have become the ideal home for millions of brown rats, but are a poor habitat for any other form of wildlife. Hard, impermeable urban surfaces create dangerous flash floods. To move ever greater amounts of urban stormwater, we've built ever larger, ugly concrete culverts that make attractive, dangerous playgrounds for inquisitive youngsters. To keep them out, we've had to build expensive, heavy grills that can block with debris and need regular cleaning and maintenance. But adventurous youngsters will always find a way in, sometimes only to find themselves trapped at the other end. There have been several incidents where the emergency services have had to be called to the rescue. Few really understand the risks, but flash floods pose a serious danger to maintenance teams as well as children. Anyone near a culvert can be hit by a sudden wall of water almost without warning. The problems of all this extra water are often simply moved downstream, causing flooding elsewhere, eroding riverbanks, causing a build-up of sediments and damaging wildlife habitats. In turn, this means more maintenance work, flood defense and channel clearing. Extra cost for something which is not sustainable. The drainage systems themselves can also have a serious effect on river water quality. A dual sewer system causes confusion. Discharges that should go to foul sewer, but instead are wrongly connected to storm drains, are common. Periods of dry weather create a build-up of contaminants from traffic and other sources that can be suddenly flushed into rivers by summer storms, causing severe pollution. These pollutants include metals, oils and dust from vehicles, effluent from factory yards, dog fouling, and rotting organic matter. Washed off every road and pavement, in even a small town, it adds up to tons of potentially toxic sediment that can kill life in the river, reduce the quality of amenities, and damage habitats. It's estimated that 20% of poor river water quality is caused by diffuse pollution from urban runoff. In some areas, it may account for half the pollution in the river. Neither are our traditional drainage systems very good at dealing with accidental spills, which can rapidly find their way to a watercourse or seep down to contaminate groundwater. And when it isn't flushed into rivers or the ground, all this pollution ends up in gully pots. These have had to be incorporated to prevent the drainage system silting up. But they often block, flooding carriageways, and require constant and expensive maintenance. And then there's the cost and problem of disposing of the sediment. Gully pots also contribute to the destruction of wildlife in unseen ways. Newts and froglets fall down the gullies in great numbers during spawning season. Unable to climb out, they starve or are poisoned in the sticky mire below. With many millions of gully pots in service, the unseen impact on our wildlife is devastating. This newt and an emaciated frog were rescued in time. But the same survey found 17 dead newts in a few gully pots on a single street in a single day. Limitations of sewer capacity and pollution from storm overflows can restrict urban development and regeneration. For example, where the foul sewer still has to carry stormwater in what are known as combined systems, increasing storm overflows to watercourses to accommodate greater populations are simply unacceptable because of the pollution caused when raw sewage is washed into rivers during heavy weather. Victorian engineering has left us with an unsustainable legacy. How can we overcome these problems? Part of the answer is to be found by taking a look at a simple change that has occurred in the last few decades. Because virtually all our sewer systems were once combined, with a single drain to carry both rainwater and sewage, our approach to stormwater has been the same as it is for foul: to get rid of it as fast as possible. But now that much of our drainage systems are separate, foul sewers for wastewater and storm drains for surface water runoff, we have an opportunity to rethink our attitude to urban development. We can use water in a more imaginative way, one that will enhance our urban areas and improve property values, while at the same time reducing many of the problems. Instead of the Victorian philosophy of trying to conquer nature, we should consider a more sustainable approach of imitating natural processes. The new methods are known as SUDs, Sustainable Urban Drainage Systems. The SUDs approach is to look at water in the urban environment from a completely different viewpoint. Instead of hiding water underground or behind concrete walls and channels, it brings it back into the community and considers all the aspects of amenity, flooding, pollution, wildlife habitats, landscape design, safety and water resources in a single integrated perspective. Natural landscape features are used to manage both the quantity and the quality of the water by slowing down the rate of flow through a train of controls that begin as close as possible to the initial source. The basic philosophy is simple: to manage rainwater near to the point where it falls, and where appropriate, allow it to seep into the ground where there's no risk of polluting groundwater, a process known as infiltration. The general methods include the use of permeable surfaces, filter strips, swales, basins, ponds, and wetlands. Permeable surfaces are about as close to source control as you can get. These can be made simply from reinforced grass, gravelled areas, or a variety of porous paving materials. Water flows through the surface into a permeable fill or subbase where it can be stored, conveyed, or allowed to infiltrate the lower strata and recharge groundwater, where there is no risk to its quality. The fill traps sediments and helps clean up the runoff. Filter strips are gently sloping areas of ground covered with vegetation, such as wild grasses. Swales are long, shallow channels used to convey water slowly and allow infiltration. As stormwater washes off an impermeable surface, such as a road, the vegetation traps suspended particles in the flow, filtering it as it runs into the swale, where the remaining solids are collected through sedimentation. Organic and mineral particles are then incorporated in the soil, and the vegetation takes up the nutrients. Polluted sediments can be reduced by natural filtration and bacterial action in the soil. Basins and ponds can be used as the next step in the management train. Basins are usually free from water in dry weather conditions, but act as a buffer to the flow during storms. Ponds, on the other hand, usually contain water throughout the year, but are designed to hold more when it does rain. Ponds and basins are often used in combination. The objective is to control flow rates downstream by storing floodwater and releasing it slowly over a period of hours or even weeks once the risk of flooding has passed. During this period, solids in the water settle out. Pollutants, held by the vegetation and soil, are reduced by biological activity.
Here we have what is a drainage feature. It's a balancing pond, but it's designed in such a way that it creates a new landscape feature on the edge of this substantial development, on the edge of Bishop Stortford. You have here a water feature which is doing a drainage job. At the far end there, you've got a set of reed beds. They're actually there to absorb pollutants and harmful organisms coming from the development itself. So they're actually purifying the water. They have great benefits for water quality, as well as providing an attractive feature of this pond and the development itself.
Swales avoid the need for gullies and their associated maintenance costs and provide guaranteed drainage from the road surface. And instead of killing wildlife, they enhance it. Neither do suds need dangerous, unsightly culverts, which are expensive to build and maintain. The risks of wrong connections are reduced when there is only a single sewer to be connected to. Conventional systems, with impervious catchments that increase surface water runoff, contribute to flood risks. This can restrict development opportunities downstream. Put simply, they're an economic disadvantage. Systems that use infiltration, basins and ponds reduce flooding risk and enhance amenity and property values. They also reduce the pressure and stresses on existing drainage systems by reducing the load. Suds improve water quality. For example, it's estimated that half the oil that ends up in the sea comes not from major tanker incidents, but from spills, factories and car parks that are washed down surface water drains. Or from DIY motoring enthusiasts who, through ignorance of the law and the drainage system, pour waste oil down the nearest and most convenient grate. By using these new sustainable methods to delay storm flows and treat pollution before it gets to watercourses, rivers and seas will improve. This in turn creates the opportunity for river restoration and improved amenity value.
We've got the River Ravensbourne here, which has been moved because the Docklands Light Railway had to come in, and instead of having the long straight channel, we've now reinstated the meanders. We're actually delaying the rate of flow when we're actually reducing the rate of runoff, and so for flood risk management it's much better. And this is a change from what we did before, which was we made the channel sort of shorter, straight, deep. What we're trying to do is mimic natural systems, and to use the natural systems to trap the particles in the root systems of plants, and to try therefore to improve the quality of the water that goes beyond there. So you're trying to reduce the amount of flow that's going off so quickly as it does in urban areas, and you're trying to improve the quality of that water as well. The benefit of producing a river of this sort of nature is that you actually improve the habitats, you improve the range of habitat. That enables species such as birds to migrate up and down the river corridor, and other animals as well. And we're seeing sort of increased species using these sort of inner urban areas.
Wildlife can be enhanced not only in existing rivers, but within the sud structures themselves. New ponds will replace many that are lost every year, along with their associated wildlife, providing opportunities for education and recreation.
Certainly as part of the schools education, an area like this is tremendous, because I mean it actually enables schools to use it as a resource to bring parties of school children to an area like this to watch its development through the course of a year, to take specimens, of course, of organism out of the pond, to look at the function of the reed beds at the top end, to look at the variety of birds that you have attracted to a pond like this.
But children are also attracted to water. Is it safe to build ponds near to residential areas where youngsters could be at risk? This balancing lake in York was built 15 years ago and is fronted by housing. The local community has had time to consider the risks.
I think it's quite a safe place for them. When I'm down by the river, I've got to constantly watch them because it's deeper. I'm worried in case they do fall in, even though they can swim. But being on here, I've no worries about them. There's no deep drop-offs. It gradually goes out from the edge, and I think at the deepest part, it's only 4 or 5 foot deep. So if a child was to get in difficulty, but I think it's unlikely as it's so shallow.
So much for theory and small-scale developments. But how do these systems work on a larger scale, which can have many more complexities?
The Dunfermline East Expansion Area is an area created to take 5,000 houses, a 36-acre leisure park, a new Tesco superstore, community centre, 3 new schools, and about 3.5 million square feet of industrial and office space. The problem with the Dunfermline East Expansion Area was that all the burns which drain it feed into the Keithing burn, which had flooded for 4 years previously because of the amount of development that had taken place upstream. And the East Expansion Area couldn't take place unless we found a solution to it. We use nature to do the job for us. And the water, instead of going into the normal gully pots, which require cleansing, goes through the holes in the curbs into a filter drain. That filter drain then leads into a swale, and it's held in those swales, again in storm conditions, retaining the water to the same rate of flow at the outlet as it was when it was a greenfield site. One of the other forms of source control that has been used is on the new Tesco supermarket site, where they've used what is called form pave, which is a block pavier with gaps down the side so that the water flows between the block paviers into a gravel substrata. Just ahead of us here, there is one of the innovations that we introduced in the middle of this large roundabout on the dual carriageway. We put in one of the attenuation basins, and it takes all the drainage from the roads and it holds it there for up to 12 hours after a storm before it gradually drains away down to one of the other treatment ponds. All the drainage from the area drains through some attenuation basins into the treatment pond, where the water stays for 14 days and pollutants like oil are degraded by the organisms in the water. In the summer we found out that the water in all the ponds was crystal clear, except for one occasion when one of the contractors washed out a ready-mix concrete truck on his site and it washed down into the inlet to one of the treatment ponds. It was immediately visible and we could trace it back and find the culprit. That's one of the benefits of this type of drainage. You can actually find out the source from which the pollution is coming. And we're very conscious of safety, so the design of all these treatment ponds which hold permanent water is done in such a way that we prevent the possibility of young children straying into them. If kids get into a culvert and there's a storm, they're trapped, they get drowned. Where there is an area of still water, we have used very shallow banking in the pond itself, and before they can get to the bank, they've got to go through some pretty jaggy, impenetrable planting. So with these built-in features, we reckon that it's as safe as it should be. From the developer's point of view, now the infrastructure is in, The value of the land overlooking these structures is greater, the saleability of the houses is quicker, and the prices achieved are greater. As part of public open space, they are attractive and they're doing the job. Without them, Dunfermline East expansion area could not have been built.
Here alongside the M40 at the Oxford Motorway Services area, the developer used SUDS techniques in the construction of the new services. The original proposal was to discharge surface water via a 1 metre diameter drainage pipe to a river some distance from the site. But the employment of SUDS techniques meant the outlet pipe could be reduced to a mere 150 millimetres and discharged to a small nearby stream, with significant cost savings.
Probably this is as densely used a site as you could imagine, with more opportunities for pollution, more opportunities for damage than you would expect on, say, most commercial sites or housing areas or whatever it is. So there are a number of collecting systems which collect the surface water runoff as it comes down. You've got the roof system, and that's collected in a series of ponds around the building. They're used both as, for ornamental reasons, but they're actually doing a job as well in picking up the roof water. This is called an interceptor pond, and what's happening here is this is picking up all the water that is either going into the car park, which is picked up in porous paving, or it's picking up water around the HGV park and the road systems into infiltration trenches. The water that goes there, which may be polluted with oil or other substances like orange juice or milk, depending what comes down, a lot of the HGV vehicles drop things like hydraulic fluid or brake fluids onto the hard standings. Those trenches begin the cleaning process, and the longer the water stays in them, the longer the cleaning process can go on. Eventually, it comes into this interceptor pond. It stays here, there's a retention time, if you like, which allows the pollution to be broken down, either be it oils or other forms of organic pollution. The water is collected slowly, it's cleaned on its way through the system, so before it actually leaves this site, it's essentially clean, and it's leaving this site, as it were, as though this were a greenfield site. So it's designed to take the water to the, if you like, the discharge point into the natural watercourse, as though this development hadn't occurred. But these systems are hugely resilient. So even if you get a big spillage, they can break it down slowly, and if the worst comes to the worst, there is a series of systems here. So if the porous paving doesn't get it, if the infiltration trench doesn't get it, then this interceptor pond will get it. In absolutely worst case scenario, it can, even if it bypassed this system, it would go down a floodway swale, and that would trap it. So you've got every insurance policy that you could imagine in these sustainable urban drainage systems, which you don't get in conventional systems. And if the worst case occurs and the whole thing floods, as it did on one occasion because we'd had a very severe storm one weekend, the landscape can take that. Whereas, of course, a pipe can't take that. Once a pipe's full,
When taken together, the arguments for using SUDS techniques are overwhelming. Controlling water quantity, improving water quality, and developing amenity value at the same time. The techniques and advantages are well proven, and technical guidance is available.
I think it's a good thing. I think we will see better developments, more attractive developments, and most importantly of all, much less pollution.
Well, all the benefits together add up to sustainable development, and sustainable development is looking at the benefits not only to the environment, but to the development, the economic regeneration of an area, and to society as a whole.
The landscape, the water environment, the wildlife environment, all of these things benefit from SUDS systems going in.
Social, economic, environmental benefits, put those together, you've got sustainable development. It's common sense.